Welcome to the Profile Corner. Today's video is part 2 in building the 3D Pantograph. I have in front of me the Pantograph unit that we started working on in the previous video. And so far what I've done is I've cut down the table surface and I cut it down to 28 inches by 40 inches, which is a little bit larger than what I thought that I would be cutting it to at the end of the last video. I'll insert a couple of video clips now that show the cutting process over at the table saw. That first rip was just a roughing rip. I cut the board extra wide. I knew that I was going to have trouble feeding it through because my crosscut table here is sticking up, and so I couldn't have this board flat against the tabletop surface, which means that I could not use both of my guides to help keep the plywood tracking square to the fence. And so what I'll have to do then is to clean up this edge because it's not square along the length, and then once I get this edge squared up, I'll square up the other edge, the back edge. But first what I want to do is I want to cross cut this to 40.5 inches, and then I'll flip it end for end and then cut it down to 40 inches wide. So first what I'll do is I'll clean up the edge that was cut earlier when I was ripping. I'll cut it down to 28 3/4, and then I'll flip the board over and I'll clean up the factory edge, which is this edge back here. Cut it down to 28 inches. I've got the Pantograph mounted onto the plywood so that we can take a look at its range of motion. As you can see, I can make it all the way over to the one edge here, and then I can make it all the way over to the other edge. And so I think that this table surface size will work. And while I can make it out to the front of this table surface, because as I mentioned in the last video, if the pointer makes it out to this spot right here, the router is going to be overlapping where the router template is at for the Pantograph. And so that won't work out. But I can use this area out in the front for clamping down the template onto the work surface. I've got the Microjig hardware here that I'll be using, at least most of that Microjig hardware. So I've got to cut dovetails into this board going across so that the Microjig hardware will be able to slide in to the surface. So I'll be doing that shortly. I'm currently 3D printing some foulers that'll go into the Pantograph, and those should be done in the next 5 minutes, hopefully. I'll take the camera to the shed where I've got the 3D printer located right now, and we'll take a look at the printing progress. Sorry, the lighting's not very good in the shed here. However, it looks like the printing process completed a couple minutes ago, and unfortunately it appears as though some of the foulers that I printed with narrow bottoms fell apart, and so now I've got quite a bit of 3D printing filament off to the side of the bed of the 3D printer. So I'll have to clean out that mess, and hopefully I've got enough foulers here that will be useful. Come in a little bit closer and you can see that I've got a couple foulers that are in millimeters in the back there, and then a couple foulers in the foreground that are in imperial measurements. And on the imperial measurement foulers, I put a bevel on the top of them so that I may be able to easily identify which ones are imperial. I also made those a little bit taller than the metric foulers. The fouler caps are designed so that the 3/16 inch shafts will just fit down inside. These holes are roughly 1.5 thousandths larger than 3/16 in diameter. And so I've got the different shafts here. This one is for 1/4 inch wide straight bits. This is a 1/2 inch wide. This is a 3/4 inch wide fouler. This would be for like a 3/8 inch wide straight bit. There's a 1 inch wide fouler, which would be good for a 1/2 inch wide straight bit. And then I've got various metric sizes here. This is 10 millimeters, 12 millimeters, 15, and 22. I have mounted into the Pantograph right now an 8 millimeter fouler, and I've temporarily double-sided taped this rail onto the plywood table surface so that I could mount this spiral template onto this, so that we can just give a real quick demonstration of how this will work. So we'll be putting the piece to be cut down in here, and then we can tip in, and as you can see, as we tip in, this bit is going to be coming in at an angle until we're at the same height here as what the router bit's at. And then once we're in the slot, then we just simply go around and around until we reach the center right there, and then we can pick it back up and shut the router off. So it's a simple process. Now we need to get these dovetail slots cut into this table surface so that I can use the Microjig hardware. By printing the foulers upside down, I was able to get these to print out on the 3D printer. This is a 6 millimeter fouler. It's a very thin one that wraps around the 3/16 inch shaft. This is a fouler for a tapered bit. This is a fouler for a 1/4 inch round nose bit, and also a 1/2 inch round nose bit. So I don't have enough shafts cut down to length yet. I'll have to cut some more. I've drawn in lines every 3 inches on center all the way around the surface. For those lines that are going across this way, I actually started here in the center, right here, and I went over 1.5 inches, went over 1.5 inches, and then from there I went over 3 inches. And so I'm ending up with a little bit extra out here on each end, but I don't think that's going to be a problem. And then I've extended these lines back roughly 2 inches beyond the last line here. I want to make sure that I don't run into the block that'll be secured right back in here. Before I start cutting these dovetail slots, I want to take a 1/4 inch roundover bit and run around the top edge and also the bottom edge, just to make it a little bit nicer when I pick this up. most likely to get a splinter. So I'll take care of that right now. I have two routers set up. Both of them have 6-inch diameter sub bases, and I have the straight bit for the Matchfit system in this router, and then I have the dovetail bit mounted into this router. So because I've got a sub base that has a 6-inch diameter, that means that I can put my straight edge on every line just to the one side of the line that I'm going to be cutting. And then I should be able to use that to make sure that the router is headed straight across the board. So I'll be starting out cutting this first slot. Because the edge guide is over here, that means I need to move the router in this direction going across so that it tries to feed itself into the fence. So I'll make one pass with this router, and then as soon as I do that, I'll take the vacuum hose off and put it onto the other router, and then I'll make a pass with it, like going across. Okay, the first of many dovetail slots have been cut. Here I'm moving through one of the Microjig hold downs, just as an example. So now I'll continue cutting all the way back off camera, and I'll probably bring the camera back when I start cutting these slots here. I'm getting ready to cut the perpendicular dovetail slots now. I just need to repeat that same process for all the remaining slots. I've started using blue tape to mark the end point. It's a lot easier to see than a pencil mark, especially when this dust collection unit is mounted onto the router. Also, when I'm using the dust collection hose, I was originally having the hose draped over the front side here, and that was causing the board to shift quite a bit while I was trying to pull the router in that direction. So now I've been trying to have the dust collection hose come out of the back side there so that I'm actually pulling the hose in the direction that it wants to go. I'm going to continue cutting these slots now. I'm preparing to do the first test run with this Pantograph, so I'll be installing this pointed roundover bit into the trim router, and then we can try to do some testing. I did a similar test using a horizontal Pantograph, and it turned out pretty nice using these same templates and the same router bit. And so I thought I would try it using this Pantograph and see how it works out for us. And I'll be using a couple different foulers, including the pointed one here, so that I can get a bit of a 3D effect in some of these templates, such as down into here. Okay, I've got a few more things that I need to get set up, and then we can give it a try. Just getting ready to do the first test run with this Pantograph. I've got a second camera set up down here in the line of view of the cutting path. First, with 8mm fouler, I'll follow this around, and then also the smaller spiral, and then we'll switch over to the 6mm fouler and do these, and then we can try out the tapered fouler that I've got here on these last couple out here. I have to be a little bit careful when I come into the template because the bit will already be touching the board, so I've got to be extra careful where I place the fouler. I have a slight problem that these clamps on the end are not holding the board in position. So I'll have to fix that, and then we can go back to cutting again. I also have the bit set a little bit too deep, and I can adjust that just by adjusting the fouler here so that it's sticking out a little bit further. Okay, I've got the clamps resituated. Let's cut the second spiral. Okay, the second spiral's been cut, and once again I've got the bit depth set too deep, so I'll have to make some adjustments to that as I put in the new fouler. Okay, we're ready to do the cutting, and I've got to be real careful here because the bit is going to touch before the fouler makes contact with the pattern down here. Okay, so some of these are working real well and others are not. Unfortunately, I didn't create enough of a background on some of these to allow tracing around the outside. It works better on the horizontal pantograph than it does on this vertical one. So let me swap out the fowler to the tapered fowler, and then we'll do the insides of these last couple templates down here. Now this bit is probably the wrong bit to use to showcase the capabilities of the 3D movement. Let me take these off the workbench here and I'll bring them up closer to the camera so that you can see them. For the first test run of the Pantograph, these didn't come out too bad. I had a little bit of difficulty controlling the Pantograph in a couple locations, and it's a little bit easier to control the depth of cut with my horizontal Pantograph than it is with this one here that tips in. But this one is able to do 3D movement while the horizontal Pantograph is not able to do that. So the templates, obviously you can customize them however you'd like, and you could also make them quite a bit larger. So this template here that was too large for the horizontal Pantograph is actually about half the size of the maximum that you can actually do on this device here, so that if you wanted to create a larger spiral, you could do that quite easily. This is the largest spiral that I could create on that horizontal Pantograph, and that spiral is right here. It looks like I also did a plus on the horizontal Pantograph, but here's the one with the question marks right here, and That one is right here on the device that we just used. So it works out pretty nicely. This is a heart template, and the heart template with a horizontal pantograph is right here. So it looks a little bit different. I'm sure that that has to do with how deep I had the router bit set. Here it was more or less ideal set, and this here I was more or less guessing how deep I need to go with it, because I was also having to tip into the cut. Whereas with a horizontal pantograph, I can come straight in instead of tipping in. Okay, that's all for today. Thanks for watching. Bye.